I would like to start off our discussion actually in code. I want to put out some ideas about how we might write some code to solve a particular issue and see what the challenges are with the solutions that we come up with. And I want to do this because it's going to steer us into the idea of objects and object-oriented programming, so we can understand what problems or what challenges they're actually intended to address, why we would think about programming in terms of object-oriented programming, why we would change our mental model for how we write code. So let's just write a real basic one. I'm going to call it circles.py. And let's imagine that our job here was to draw some circles on the screen, an arbitrary number of circles in an arbitrary position from arbitrary colors. So we might say circle radius equals, 7.2. So that would be a fact of the circle that we need to draw on the screen, and then we could call it, draw circle or whatever our function was, circle radius. Perfect. Well, we also need a position. So we would have circle x is 164 and circle y is maybe 320, and that would represent like some xy coordinates on the screen where the circle was going to be drawn. We might have a circle color, so this circle is going to be green, so we know what color to draw it. And you know what, is it filled or not? How about circle filled? And we'll say this is true because it will be filled in. It would be false if it was just a circle outline. So this is obviously my draw circle function does not exist, so this doesn't actually work, but you could imagine this code working. If I had some code to draw the circle on screen with draw circle, this would draw me a circle. Now what if I needed to draw a second circle? Okay, well, I'm just going to copy all of this code, and you already should be going, wait a second, right? And I could put in the details of my second circle here. Maybe this is 5.4, except this would mean to be circle radius 2 and circle x2 and y2. And these would need to be in a different position as well, 292 and 282 maybe. Instead of green, it's going to be red, and I want it to be false because I don't want this one to be filled in. So you can start to see how we could build these circles here in code. But of course, this is a problem. First of all, there's a bunch of repetitive code here, right? You see that listed up on the screen, just over and over and over, the same variables listed. And I can't handle an arbitrary number of circles here. If I have to read in the circles from the user or from a database, well, if I pre-program the variables like this, then I have to use exactly that number. So what do we do here? How do we solve this particular challenge? Well, we've learned some techniques for dealing with this, largely for dealing with sets of data. So instead of dealing with these circles like this, you know what? I could have a series of lists that had all these variables and values. Circle radii like that, and circle x and y, and colors, and circle filled, right? Now I've got a bunch of circles, and if I needed to add a new circle, I could just append a new value onto the end of each of this. Of course, that would change the way my draw circle function looked. My draw circle function would now need to reference each one of those variables as I passed it in, maybe something like this. And this helps. This is better because, now I've got a variable number of circles and I can address them individually using that index inside of each array. But, it's still a bit of a pain in the butt. If I need to add another property onto my circles, well, then I've got to create a new array and fill it in up with all the proper values. You can see it's still some pretty long verbose code. For instance, when I call my draw circle method, that's a little bit difficult. And actually, even if draw circle were a functioning piece of code, this code up here would error because, of course, I forgot to add the last value, the fourth value, onto my circle x list, which means there is no circle x3 index, which means I would get an index out of bounds error on this. And it would be difficult for me to figure out exactly where that index out of bounds error was when looking at this. I'd be like, it's a little bit confusing. It's kind of obvious when there's only 4 values in there, but what if there were 10 values or 20 or 100 values in there? Or what if I was reading this out of a database and there was an error during the database read and I didn't actually have a circled data inside of that particular index? Okay. So this is the problem. There's some solutions, there's some way we can deal with this, but this is the thing that object-oriented programming actually allows us to do. Wouldn't it be cool if I could do something like this? If I could create a new variable that represented a circle, and I just call it new circle, and the variable will be C1, and then I could reference that individual values by referencing C1.radius or C1.x and C1.y. What is this accomplishing for me? Now this would be, I don't know what it is, 6.2, and x is 150, and y is 174. So this would be kind of cool being able to do this, right? Notably, I could create this line here by just say C1. Now I'm calling my draw circle function, and I'm just passing in a variable C1 because the C1 variable contains all of these other variables, all of these other attributes or properties or traits. And I could create, I could create a list of circles. I could say circles equals C1, comma C2, comma C3, right? And up here, I could fill in C1, C2, C3 as needed. So I've got these variables that represent something. They represent specifically a complex type of object that I've called a circle. A circle has a number of different traits associated with it. It's got a radius, which is really the size of the circle. It's got a position, the x and y variables. It has a color, and it's got a Boolean value, a true, false, to indicate whether or not it should be drawn as an outline or filled in. This is an object, and this is object-oriented programming. And we're going to pause here and switch over to our slideshow to talk a little bit about what this is. What I've just described are classes and objects. A class is a description of a type of object. So a description of a circle would be the class. And the object itself, the actual circle variable, represents that collection of all the traits and behaviors that make up that object. So the circle with a capital C, that was my class. And then my instance of that, C1 for instance, that was my object. And the object contains all of that information, and we can create these. You got to think of these objects as variables. Instead of a primitive variable, which just contains one number or one text value or one Boolean value, true or false, an object is a variable that contains multitudes of those, can contain many of those, and they can be all mixed up. It's kind of like a collection in that sense. It's a very, very similar, and that's why when I first showed my sample there, I showed off how we could use collections. We could use lists in order to solve that challenge. But as you will see momentarily here, classes are even more powerful than lists. Now, importantly, sometimes people will use the phrase class and object interchangeably, but classes are not objects. They very much are not objects. A class is its own separate thing. I like to think of it as blueprints and houses. With a blueprint, you have an awesome description of how to build a house. These are your instructions. And from that blueprint, you can build a house, and it contains all the traits of the house. It contains where the walls are, how tall they are, which rooms there are. It even, on a blueprint, indicates behavior of the house. It'll show you which way the doors swing, for example. But notably, the blueprint is not the house, right? These are two separate things. A blueprint is one thing. It's a piece of paper that tells you how to build a house, but the house is the actual thing. The house is the actual object that you build from those blueprints, and the objects can be different, right? You can have multiple houses from the same blueprint that might be different than one another. You can change the color of the roof. You can maybe add on an optional 2-car garage. There are choices to be made when you actually build from the blueprint in the actual object. So the blueprint is our class in this situation, and the houses are our objects. And we can set up this exact same structure inside of our Python code using the class definition. So here is what we are going to do. We are going to create a new class called circle, and that is going to be the class keyword. It'll be called circle, open and close parenthesis, and a colon. This new class circle needs to have a number of different variables. For instance, it needs a radius, and it needs an x, it needs a y, it needs a color, and it needs a filled value. And notice I have given each of these what we'll call a default value. So it starts off fairly basic, right? That is our circle class. If we wanted to create a new instance of that circle, the syntax looks like this. C1 equals circle, open and close parenthesis. All right. I have created a new variable called C1, and C1 contains all of these values, all of these variables. So I've got a radius, an x, and a y. C1.color is going to equal blue, for instance, and C1.filled will be equal to true. So now C1 is this entire variable that has all of these values. And I could, for instance, print individual values of this, again, using that period notation. So print C1.x. This is going to get the x value out of my C1 variable, which in my case should be 150. Save this, give it a quick run. And there it is, 150. In fact, I can print the entire object itself. If I leave off that dot and I just print C1, C1 is all of the collection of properties that represent that object that I created. Again, notably, this class up here is the definition. This tells me the structure of my circle. It tells me what variables every circle is going to have, but it does not tell me, for instance, what actual color that circle should be. So now I've got C1. I could do the same thing with C2, and I could create a C2 object. Something like this, and now I've got two variables. I've got a C1 and a C2, and I could create it, like I said, a circles list that was equal to C1 and C2, just like that. Now I've got a new list that has both of those variables in it, and I could print circles one dot, yeah, you look at that, filled radius XY. My tooltip knows what the options are for circle objects, so I could say print C1.y, and that is going to show me 400 if I am getting this correctly, and there it is, 400. So we've built up this object definition, this description of an object, in our case, a circle. We've described some variables, some values that a circle needs to have in order to be a circle. We call these the traits or the attributes of our object. We then created a couple of objects from that class. So we instantiated this circle object into a variable. I called one of them C1, one C2. And those variables are just like any other variable inside of Python, except they don't have just one value associated with them. They have multiple values associated with them. They have subvariables or child variables that represent each of those traits that were inside of our class, so that we have all of that information bundled up into one variable, even though I can still reference it individually by referring to the individual values, the individual variable names, using dot notation. So how does all of this help solve the problem I described at the top of this video? Well, check it out. Instead of doing individual variables, we could create, I don't know, a for loop. So check it out. Here I'm going to loop through 10 times, and on each loop I'm going to ask the user to enter a radius, store it inside of this variable C, and then append that variable C onto my circles list. Then I'm going to loop through and I'm going to overwrite the existing variable C circle with a new one, and I'm just going to create these over and over and over. So for instance, I could come down here to number 6 and print out the radius of circle number 6, and look at how short and simple this code is. I'll save that, I'll give that a run. And what's the circle radius? Now I'm on the first loop, so we'll say 10, 20, 30, 40. Okay, and then circle number 6, which is the 7th item in my list, had a radius of 70 because that's what I entered into it. So I've got this incredibly short amount of code to fill in 10 different circle objects. Each circle object has 1, 2, 3, 4, 5. That's 50 variables, 50 values I could fill in inside of this little loop if I asked or pulled those values from any one place. So the object has created a number of different features, a number of different benefits for us, and we're going to dive deeper into how these work in our next video. But it is a single variable based on a class, based on a structure that was described in another place. And of course, we could put this class definition inside of another Py file and import it at the top and get it right out of this code file. That class structure tells us what variables, what values are associated with our object. So a circle object has these 5 values associated with it. Every circle object that I create now has these 5 values associated with it. It's going to show up in my tooltips. It's going to communicate that to me or to whoever is writing this code and working with this circle object. I'm going to know what values I have available and what values I should be attempting to fill in. If I need to add a value, if we change the circle object, you know what, we decided it also needs a shading. Is it going to be solid or cross-hatched or vertical lines or horizontal lines? Well, we could add that to the class definition, and just like that, every instance of our circle would now have a shading variable associated with it that we could update and use and change as we need it. So we have this complex object described in one place, and we can access it in a standard fashion all throughout our code. In our next video, we're going to dive a little bit deeper into those properties, those variables inside of our class definition that are known as attributes, and we'll talk about object behavior. I hope this has been informative for you, and I'd like to thank you for viewing.